Hey, welcome back. So up to now, we really haven't tried to give each atom in a Lewis structure a charge. In fact, we normally just put the whole thing in brackets, right, and we wrote the charge next to it. But it turns out there is actually a way to assign charges to the individual atoms, and this is called formal charges. So for example, let's go ahead and take a structure like ozone. In fact, ozone doesn't look like it's got a charge at all, but it turns out that actually some of the atoms do have a charge. And we'll see that it all adds up to 0, but if we just write 0, we'll actually lose something kind of interesting here. How do we do formal charges? What we have to do is we have to ask ourselves, originally, how many valence electrons did each atom have? And that is just the group number, remember. And then we have to ask ourselves, well, now, how many valence electrons does it have? And in order to answer the question of now, how many does it have, it gets to keep 100% of the lone pairs, and it gets to keep 50% of the bonding pairs. So that is exactly half and half. So what we're going to go ahead and do here is we're going to assign them. So this oxygen here gets to keep 100% of that lone pair, 100% of that lone pair. So that's 4. And each bond, right, is 2 electrons. So it gets half a bond. So there's 1 there and 1 there of the share, right? So it gets 1, 2, 3, 4, half of that bond, half of that bond. That's a total of 6. And if we look at the center one, this is actually where it's kind of interesting, because the center one, if we look at it, it's got a lone pair. It gets to keep those 2. It gets to keep half of that bond. So that's 1. Half of that bond, that's 1. Half of that bond, that's 1. Remember, a bond's 2 electrons. So half a bond is 1 electron, 2 electron, 3 electron, 4 and 5. And now we can see there's a difference between those two numbers. And if we look at the last one, then we've got 2, 4, 6 from the lone pairs, and half the bond is a total of 7 electrons. And when we write the formal charge, essentially what we do is we ask ourselves, does it have the same number of electrons now as it originally did, in which case it's neutral. However, if it's got 1 fewer electron than before, then if it's lost an electron, it's got a charge of 1 positive. And if it has gained an electron, like the one on the end, right? So it started with 6, and now it's got 7. It's got 1 more electron, so formally its charge is going to be 1 minus. And so we can write those as the formal charges. So we often don't write the zeros on there, but we can write the plus there, and we can write the minus there. Now, another way you can calculate the formal charges, right, is you can just subtract that away from that if you like. So 5 minus 6 is positive 1, 7 minus 6 is minus 1. But I always like to reason it out, right? If it's lost electrons, it's positive. If it's gained electrons, it's negative. But that's essentially how it works. So let's go ahead and look at one more example. So let's look at the nitrate ion, right? So originally, we went ahead and we did something like a double bond there and a single bond over there. Actually, it's probably one of those resonance structures, to be honest. But we just went ahead and we put the whole thing in square brackets, right? And we put the negative charge like that. Well, now we're ready to assign formal charges. So we just need to know how many electrons they originally had. Oxygen's in group 6, nitrogen's in group 5, and oxygen back in group 6. And we need to ask ourselves, how many do they have now? So what do? We get to keep all the lone pairs and half of the bond. So 2, 4, half of that bond is 1, half of that bond is 1. So that means it's got a total of 6 around it. If you look at the center atom there, nitrogen, it gets half of each one of those bonds. So 1, 2, and 3 gets to keep both of those. So that is a total of 5. And if we look at the far one, so what did I write there? Did I write 0? Maybe I just can't write the number 6. So how many electrons do we have around it now? We got all those lone pairs. That's 6. It gets to keep half the bond, so that is 7. And we can see that one is going to have an interesting formal charge because the first 2 haven't changed, and the last one has gained 1 electron. So formally, it has a charge of -1. So what does that mean? That means that we probably could have actually written this Lewis structure more properly, like so. So it's the right-hand oxygen that has the negative charge. So we don't necessarily need to put the whole thing in square brackets and put the charge next to it. We can actually assign which atom has got the charge. And notice that the sum of all the formal charges equals the overall charge. So that is a useful way to tell whether you've done it correctly or not. In fact, we could have kind of cheated. And if we'd known the first 2 were 0, we could have figured out the last one must have been -1, because that's the only way it would have all added up to that charge.